the echoes of life resonate through the vast expanse of the Everyverse, a cosmos teeming with possibilities. Each star, each planet, a potential harbor for life waiting to be discovered. The discovery of exoplanets, worlds orbiting stars beyond our sun, has ignited a profound shift in our understanding of the cosmos and our place within it. Once confined to the realm of science fiction, the realization that our solar system is but one of countless planetary systems has fueled an insatiable quest. The search for habitable exoplanets, celestial bodies where conditions might be conducive to the emergence and sustenance of life. This endeavor, driven by sophisticated telescopes and intricate atmospheric analyses, operates within the established framework of four-dimensional space-time, seeking worlds that mirror Earth's life-supporting characteristics. However, the 11-dimensional model, with its expansive architecture encompassing a hierarchy of interconnected realms, offers a tantalizingly broader cosmic context for this search, suggesting that the very definition of habitability and the prevalence of life itself might be intricately woven into the fabric of a multi-dimensional everyverse far exceeding our current comprehension. Our current scientific paradigm for assessing exoplanet habitability primarily focuses on factors observable within our four-dimensional spacetime. The concept of the circumstellar habitable zone, often referred to as the Goldilocks zone, dictates that a planet must orbit its host star at a distance where liquid water, deemed essential for life as we know it, can exist on its surface. The type and stability of the host star are also crucial, as are planetary characteristics such as size, mass, atmospheric composition, and the presence of a magnetic field to shield against stellar radiation. While these criteria provide a valuable starting point, they are inherently biased towards life as it has emerged and evolved on Earth, potentially overlooking a vast spectrum of habitable conditions and exotic life forms that might exist within the broader cosmic landscape envisioned by the 11-dimensional model. The 11-dimensional model, as we have discussed, posits a universe with a far more intricate structure than our familiar four dimensions. The fundamental constants that govern the laws of physics in our space-time, such as the speed of light, the gravitational constant, and the fine structure constant, might not be universal, but rather emergent properties arising from the specific geometry and dynamics of the higher dimensions. Variations in the expanded extra dimensions, or differences in the interplay between the 11 dimensions in other regions of the Everyverse, could lead to vastly different values for these constants, potentially giving rise to universes with physical laws and conditions radically unlike our own. Within this broader cosmic context, the very definition of a habitable zone might need to be expanded. If life can emerge and thrive under physical laws different from ours, then the traditional requirements of liquid water, Earth-like temperatures, and specific atmospheric compositions might be overly restrictive. Exoplanets orbiting different types of stars, or even free-floating worlds warmed by internal geological activity, could harbour life forms adapted to conditions we deem extreme. The 11-dimensional model, by suggesting a multiverse with a potentially infinite range of physical parameters, opens up the possibility of an equally diverse range of habitable environments. Furthermore, the 11th dimension, as the ultimate nexus of interconnectedness, might link seemingly disparate regions of the multiverse with similar conditions conducive to life. If the emergence of life is not an entirely random process, but is influenced by underlying principles of self-organization and complexity that are inherent to the fabric of reality across all 11 dimensions, then habitable zones might be more prevalent and interconnected than we currently imagine. The 11th dimension could facilitate a subtle exchange of information, or even the transfer of basic building blocks of life between universes with similar physical characteristics. The 0 dimension, representing pure potentiality, also plays a crucial role in this expanded view of cosmic habitability. If consciousness, as we have speculated, is fundamentally linked to this dimension, then the potential for awareness and life, might be an inherent property of the Everyverse, manifesting in diverse forms under a wide range of physical conditions, guided by the intrinsic drive towards complexity arising from the zero dimension's infinite possibilities. The dynamics governed by dimensions 4 through 9, rotation, polarity, and multi-body systems, could also influence the stability of exoplanetary systems and the long-term habitability of planets within them. The precise orbital configurations, axial tilts, and magnetic field strengths, all crucial factors for maintaining stable climates and shielding against stellar radiation, might be determined by the intricate interplay of these higher dimensional dynamics. Planetary systems that exhibit long-term stability and resilience might be those whose higher dimensional geometries are particularly harmonious and conducive to the sustained emergence of life. However, it is crucial to acknowledge the highly speculative nature of applying the 11-dimensional model to the search for exoplanet habitability. We currently lack direct empirical evidence for the existence of these higher dimensions, and our understanding of how they might influence fundamental constants and the emergence of life is still in its infancy. The search for habitable exoplanets remains firmly rooted in the observable characteristics of these distant worlds within our four-dimensional space-time. Nevertheless, the 11-dimensional model offers a powerful conceptual tool, broadening our cosmic perspective and challenging us to consider the possibility of a universe teeming with diverse forms of life adapted to a far wider range of conditions than we currently recognize. The echoes of life that we hope to detect in the atmospheres of distant exoplanets might be but faint whispers from a vast, multidimensional symphony of existence, where the principles of emergence, driven by the intricate interplay of 11 interconnected dimensions, have orchestrated life's genesis in countless forms across the boundless expanse of the Everyverse. Therefore, the 11-dimensional model encourages us to expand our definition of habitability beyond the familiar parameters of Earth-like worlds, prompting us to consider the vast and varied conditions under which life might emerge and thrive within the broader cosmic landscape of the Everyverse. A crucial aspect of this expanded search, and one that offers a tangible link to our current methodologies, lies in the concept that planets with similar dimensional properties within the 11-dimensional model might harbour life more consistently. Consider the 11 dimensions as a spectrum of existence, each contributing to the overall characteristics and dynamics of a celestial body. Planets with similar values across these 11 dimensions, from the fundamental rotational frequencies and polar orientations, dimensions 4 and 5, to the complexities of their orbital mechanics within their star systems, dimensions 6 and 7, and even their galactic and cosmic context, dimensions 8 through 11, might exhibit a greater degree of overall similarity in their physical laws, environmental conditions, and thus their potential for harbouring life. In many ways, the current search for habitable exoplanets, while operating within a four-dimensional framework, can be seen as an implicit search for planets with similar lower-dimensional properties to our own Earth. When astronomers look for exoplanets with Earth-like sizes and masses, orbiting within the habitable zones of Sun-like stars, and exhibiting atmospheric compositions that suggest the presence of water or biosignatures, they are essentially seeking worlds with comparable three-dimensional spatial characteristics, similar gravitational forces linked to mass, and analogous interactions with their host star, a two-body system with comparable orbital dynamics. The presence of a magnetic field, inferred from planetary size and rotation, can be seen as a proxy for similarities in the fourth and fifth dimensional properties of rotation and polarity. Thus, the ongoing efforts to identify Earth-like exoplanets can be viewed as an initial, albeit limited, attempt to locate worlds with a degree of dimensional similarity to our own life-bearing planet. The success of these search strategies, the increasing number of potentially habitable exoplanets discovered, might implicitly suggest that planets sharing similar lower dimensional properties are indeed more likely to exhibit conditions conducive to life as we understand it. However, the 11-dimensional model encourages us to go further, to consider the potential for higher dimensional signatures that could indicate a greater overall similarity between exoplanets and life-bearing worlds within the Everyverse. Future research might explore ways to infer the higher dimensional properties of exoplanets, perhaps through subtle anomalies in their gravitational interactions, unusual atmospheric phenomena, or unexpected patterns in their orbital dynamics that could hint at the influence of additional dimensions or their interconnectedness. For instance, the precise long-term stability of an exoplanet's orbit within a multi-star system, a higher body system, might be more fully understood by considering the constraints imposed by the 8th and 9th dimensions of the 11-dimensional model. Similarly, the strength and behavior of a planet's magnetic field, crucial for shielding life from harmful radiation, might be linked to the intricate interplay of its rotation and polarity within the higher dimensional framework. The ultimate goal would be to develop observational techniques and theoretical models that allow us to assess the dimensional similarity of exoplanets to known life-bearing worlds across all 11 dimensions. Planets exhibiting a high degree of similarity across this multidimensional spectrum might represent the most promising candidates in our search for life beyond Earth, suggesting a consistent emergence of conditions conducive to life arising from a shared foundation within the broader Everyverse. The 11-dimensional model, therefore, provides not only a framework for understanding the potential diversity of habitable worlds, but also a guide for refining our search strategies, urging us to look beyond simple Earth analogues and seek out the deeper, multi-dimensional echoes of life throughout the cosmos. Thank you for watching. If you enjoy the 11-dimensional model YouTube channel, please like, subscribe, and share with a friend for more future content.